Okay, so now we're going to learn two more rules. Well, only one rule in this video, but two rules for this lesson. And this rule is called the product rule. This is going to be another incredibly helpful, useful derivative tool. Before we get into that, I want you to find the derivative of this function. So pause the video, find that derivative. Unpause when you're ready to check. Alright, so hopefully you got that the derivative is 9x squared plus 32x minus 12. And I got that by distributing, combining like terms, and then just using my power rule. Pretty straightforward. But what if it wasn't that straightforward? Well, we could use what we call the product rule. So the product rule is what it sounds like. It's for when we have products, which is multiplication. So if I have some function u, which is f of x, and some function v, which is g of x, then I know d dx, or the derivative of u times v, is u times dv dx plus v times du dx. Keep in mind, because this is addition, it doesn't matter the order in which we do it. Another way to write this is d dx of u times v is u v prime plus v u prime. So if I apply that to the same function that we just took the derivative of, I can think of this is my u and this is my v. So I know then that y dx would be u, so x squared plus 6x times v prime, or dv dx, so times 3, plus v, so 3x plus, 3x minus 2 times the u prime, or du dx, which is 2x plus 6. So that's my derivative. It doesn't look exactly like the other one yet, so we can do 3x squared plus 18x plus 6x squared plus 18x minus 4x minus 12. Combine like terms, and we end up with 3x squared plus 32x minus 12, and I messed up, I forgot about that 6, so that's actually 9x squared plus 32x minus 12, which is what we had over here. So this is an example of where we didn't need to use the product rule, and in fact the product rule actually maybe made the problem more difficult than just multiplying it out first. However, if we have something like this, now we definitely want to use the product rule. So I want you to pause the video and try to find this derivative using the product rule. Unpause when you're ready to check. Alright, so here if I say my 2x plus 3 is the u and 1 plus root x is v, then I can do u times dv dx plus du dx times v. I simplify it a little bit because I don't like the negative exponents, so this becomes 2x plus 3 over 2 root x, and then this is plus 2 root x. How much you simplify right now doesn't matter that much. We'll talk about that more as we get into some of these problems and get closer to our next assessment. One thing I want to point out, though, the reason why we had to use the product rule here was not because of the original notation. We didn't have to use it at this point. But if I was to distribute this original function, I would get 2x plus 2x root x plus 3 root x. And this term right here is still a product. So there's no way to do the derivative of this function without using the product rule. Because if I was to take the derivative of it in this format, I would be fine with this term, the 3 root x, but the 2x root x, I would have to use the product rule. The exception would be I can rewrite this using my properties of exponents, but again, at this point now, the problem is becoming easier just to have done the product rule in the first place. So yes, I do I digress. I could do this. It is possible to do the derivative of this without the product rule. However, by the time you simplify it to that form, you might as well have just done the product rule. All right, when do we not want to use the product rule? Here. We do not want to use the product rule. Yes, I could do this. I could say y prime equals negative 4 times 5x to the 4th plus 0 times x to the 5th, and I end up with negative 20x to the 4th, but I'm really wasting my time. Okay, so although negative 4 times x to the 5th is a product, anytime there is a constant here, you should not use the product rule. In fact, if you wanted to make this really difficult, you could think of this original equation as y equals negative 1 times 4 times x to the 5th, and then you could do a triple product rule, which, yes, that is a thing. I don't know if it's really called triple product rule, but you can do the product rule with 3 products. But again, you're making the problem way more difficult than it should be. So if you have a constant there, just use our normal power rules. You do not need to just revert to everything as the product rule now. All right. Know the product rule.